All right, friends, it's your boy, Mr. Shaggy, coming at you with Unit 3, Lesson 8, Scale Drawing and Maps classwork. So it says, let's use scale drawings to solve problems. The first activity is called A Train and a Car. It says, two cities are 243 miles apart. It takes a train 4 hours to travel between the two cities at a constant speed. And it says the car travels between the two cities at a constant speed of 65 miles per hour. Which is traveling faster, the car or the train? Well, currently we know that the car is traveling 65 miles per hour. So if we remember what we've done before, we found that distance equals rate times time, right? So we know that between the two cities, it's 243 miles apart for the train, right? It takes the train 4 hours, so we do not know its rate, but we do know its time, which is 4. Right? So now we know that some number times 4 will give us 243. So we need to isolate this r and get r by itself. So we're going to divide by 4 because it's currently being multiplied by 4. And the opposite of multiplication is division. So we're going to divide by 4 here, and we're going to divide by 4 here. So I'm going to set this up. So 243 divided by 4. Now, 4 goes into 24 6 times. And so you're left with 0. You bring down the 3. Then you ask yourself, can 4 go into 3? It cannot, so you put a 0. And then we don't have anything to bring down, so you need a decimal point, and then you can bring down a 0. 4 into 30 is 7. That's 28. You're left with 2. 4, and bring down another 0. 4 into 20 is 60 and 7,500. So the rate for the train is 60 and 7,500ths. So this is the train's rate. But we know the car's rate, so back to the problem, the car's rate is 65 miles per hour. And this is 60 and 7,500 miles per hour. So the car is traveling faster because 65 is greater than 60 and 7,500. So the car is traveling faster because 65 miles per hour is greater than 60 and 7,500 miles per hour. So really in this activity we're getting back to this, we're looking at scale drawings to find the distance in the drawing to then do a speed problem, right? So we have a speed problem here, and we're going to find the distance given a scale, and then use that to help us calculate or answer some problems. So just to recap real quick, remember that when we're trying to look for the speed, and we're looking for time, and we're looking for distance, the equation for this is distance equals rate times time. And then I found the rate of the train and compared that to the rate of the car and found that the car was traveling faster. And our next activity is going to be driving on I-90, so I apologize there. I did not have that out in the right order. So it says a driver is traveling at a constant speed on Interstate 90 outside Chicago. If she traveled from point A to point B in 8 minutes, did she obey the speed limit? So in this problem, we know the time. So remember, distance equals rate times time. And so we know that the time is 8 minutes, and this is 55 miles per hour, right? So we could find the distance. So we're going to find the distance using the scale here. So if you look really closely, I'm going to measure the scale using this Post-it note here. So I'm going to mark it as close as I can using this Post-it note. So there's that. So from A to B, I'm going to make some markings. So from A to B, and this scale says this 0 to 2 miles. So this represents, every mark that I make will represent 2 miles of distance. So there's 2 miles. And then there's another 2 miles. And then there is another 2 miles. And then, yep, almost the 2 miles there, so I might consider that to be 1 mile to that point. Maybe that's half of that, 1 mile. And then from there, it's gonna turn about like that. So that's about, it's almost 2 miles. So we have 2, 4, 6, 8, almost 9 miles. And that's the rough estimate, 9 miles using our index card. And that's if, so about 9 miles of distance. So what we're gonna do is we're gonna take 9 miles, right? And we're going to divide that by our speed to find time in this problem. So we're going to take 9 divided by 55. So 55 can't go into that, so put a decimal right there, add a 0. 55 goes into that one time. Subtract 55. 90, this is 8, 5, 35, add a 0, 55 into 350. I'm going to try 6 first. 30, 33, about 1600ths. And so on the 1600ths represents like the time that it would take. So roughly so 55. So what we can say from this is she obeyed the speed limit of 55 miles per hour. So in 9 minutes, right, she's going 55. So 9 divided by 55 equated to is about, I'm going to do my about, is about 1600ths. And so since she got from A to B in 8 minutes, she must have been going faster than the speed limit, So what I did here, so I just, you can't even see anything I just did. So what we did is we set up this problem, so we found that this here was about 9 miles. So I did 9 divided by 55 to see the time, right? So this represents time, or approximately about time. This is 1600ths of an hour, right? So 1600ths of an hour. So I'm gonna multiply that by 60. So I'm gonna multiply this by 60. That's 0, that's 36, add a 0, 0, that's 6. That's 9, move it twice. So theoretically, if she were, right, that's about 9 minutes, right? So 9 minutes and 60 and part of the 10th minute, and she does that in 8 minutes. So that's why we know she's traveling faster than what she's supposed to be going. So because our first number here is 9, and it says that she does it in 8, so she's going way faster than she should be. So to clarify this problem a little bit, first I measured the distance. I found that to be about 9 miles. Then I divided it by 55 to find out the time, like how much of an hour, right, this is. So it's about 1600ths of an hour. So once I found that, I multiplied it by 60 because I know there's 60 minutes to see how many minutes it should take. It should take this many minutes, and it took her 8, so I know she's speeding. It says a traffic helicopter flew directly from point A to point B in 8 minutes. So the helicopter doesn't have to follow the road. Did the helicopter travel faster or slower than the driver? Explain your reasoning. Well, if the helicopter's moving at a straight shot and it doesn't have to make those turns, right, the distance is between those 2 points would be smaller, right? So if I'm going to get my straight edge real quick to show you what I'm talking about. I should have had this out previously. So here's my straight edge. So I'm going to draw a line from A to B here. So this line, if I measure that line, right, and that's a little off, but if I measure this using that same scale, right, I'm going to show you what we're talking about here. So the helicopter travels from there to there. See, that's about 8 miles versus 9. That's a shorter distance, and so therefore it's traveling, slower. So if this line is shorter than that line because they had to do an extra turn, right? The helicopter is traveling slower because a straight line from A to B represents a shorter distance, and the helicopter took the same amount of time. Right, so what I just did there is I measured this line. I found that to be shorter distance, and if that's a shorter distance and it took them the same amount of time, then they're going at a slower rate than the person in the car. The next activity we have in the last activity is called biking through Kansas. So it says the cyclist rides at a constant speed of 15 miles per hour. At this speed, about how long would it take the cyclist to ride from Garden City to Dodge, Kansas? So we're going to do this little scale here real quick. And so this scale says, the end of the scale would represent 4 miles. So I'm going to measure this as best I can here. And then do this from Garden City so that's 4. 8, 12, 16, 20, 24. Sorry, my post-it note is sticky. 24. 24, 28, 32, 36, 40, 44, 48, 52, about 56. So there's about 56 miles. And if we want to find at this speed, how long would it take? So this is a distance equals rate times time. We know the distance is 56. We know the rate is 15, and we're looking for time, right? So currently we want to find t in this problem. So to find t, I need to divide by 15 here and divide by 15 here so that I can isolate my t. So I'm taking 56 and I'm dividing it by 15. So 15 can go into 56. 15 times 2 is 30, times 3 is 45, times 4 is 60, so it's going to be 3 times. That's going to be 45. That's 1, so that's 11. I need a decimal point there. I need to add a 0 here. 15 into 110. So I know 15 times 6 would be 90, so I'm going to try 7, 35. I think 7, that's 105. Then we're left with 5. Bring down a 0. That is 3 times again. And it's going to repeat from there. So 3 and 70. So we know it's going to take 3 hours. And then what we're going to do is this represents a part of an hour. So 7300ths represents part of an hour. So we know that there are 60 minutes in an hour. I'm going to multiply that by 7300ths. That's 0, that's 18, 0, 0, 42, 0, 8, 3, 4, twice, 3 hours and about 44 minutes. Right? So I rounded that up to about 44 minutes since the 8 is there. So this is about, I'm going to do the about symbol, 3 hours and 44 minutes. So we found the time that it would take to cycle from Garden City to Dodge City at the constant rate of 15 if the distance between here and here is 56. So that is our lesson for Monday. I hope you enjoyed this lesson. I can't wait to see you then.